Did you know that there are different types of numbers? Knowing the rules for naming and classifying numbers is essential to doing quality math at just about every level. On this episode of Montgomery Mathematics, we're going to take a few minutes to explore our number system. The number system basically developed over time in layers of increasing complexity as we started using numbers for more and more detailed tasks. By the way, I have this handout on the number system available in the Montgomery Mathematics Teachers Pay Teachers store. It's totally free, so go ahead and take a second to go print it out, keep a copy for your notes, your binder, bulletin board, whatever. So let me tell you the story of our numbers. A little disclaimer though, I'll be playing a little fast and loose with the history, but I think it's a helpful framework for understanding these different classifications. First, we can start off kind of conversationally. Think about where numbers come from and what they were likely first used for. There's probably some guy saying, I have 3 goats. I see you only have 1 goat. Numbers that we would use in this kind of a way are called natural numbers. Notice that in a conversation like that, our farmer likely wouldn't say, I have 3 goats, 5 cows, and 0 chickens. He just wouldn't mention the chickens. There wasn't much use for 0 until we moved from just bragging about how much we owned into keeping more formal records. When people were trying to keep track of their inventory, sometimes they would realize that they sold their last chicken. Well, how do you put that on your records? Thus, the idea of 0 was born. This leads us to our next category of numbers, whole numbers. Notice that I drew the circle for whole numbers around the circle for natural numbers. This is to show that everything that we had been calling natural is also considered a whole number, but now we're also including the number 0 as well. Now, what if our farmer friend comes back from the market after selling his last chicken? And at the same time, his son comes up very excited and says, Dad, I just sold 10 more chickens. I just came home to pick them up. Well, that's a great sale, but that brings us to a new problem. And that new problem brings us to our next type of number. See, we haven't just run out of chickens where we would use that fancy new 0 in our records. We actually somehow have less than that. We have to go and find 10 more chickens and give it to the son's customers before we're even back to having 0 chickens. This is called a negative number. And when we include the negatives in with the numbers that we've already been using, now we're talking about what we call the integers. Again, integers include all of the numbers that we've talked about before, but we're also including the negative versions of those numbers as well. Up to this point, we've been using our farmer's family as our example. But as history goes on and economic systems and transactions got more complicated, so did the number system. People started dealing with larger quantities of goods. They would join together to make even bigger deals, and then they would have to split up their sales and their profits. Well, if you and 2 of your friends all pitched in to buy 1 big jar of grain, how can you split that up fairly? It's easy to think of ways to do it physically, such as pouring the grain out into 3 equal piles and each person just takes 1. But what do you do with those pesky record books now? See, you're not coming home with a jar of grain, but you're also not coming home with 0 jars of grain. You're coming home with somewhere in between those 2 values. In fact, you know that you have exactly 1 of 3 equal piles of that grain. But how do you write it? This type of situation is what led to the idea of rational numbers. Rational numbers are any number that can be written in the form of a over b, where both a and b are integers and b is not 0. Remember, we can never divide by 0, but that's another video for another time. These can be represented as fractions or as decimals, as long as the decimal either terminates or starts repeating eventually. So some examples of this would be 0.33 where it's repeating, or 0.5. These are all rational numbers. Also notice that I can take any integer and put it over a 1 and still have a number that meets this definition of a rational number. Thus, we can see that rational numbers, again, include every layer that we've talked about before. Let's fast forward from our little band of farmers to ancient Greece. The Greeks were known for taking numbers from a way of counting and accounting into a much more general and philosophical realm. They were especially good at using fractions, these rational numbers, and patterns that they noticed in the shapes and structures around them to create this much broader field that we now call geometry. There will be plenty of videos in the future talking about the Greeks and their different discoveries. For right now though, let's just leave it at saying that the more geometry that they discovered, the more problems they ran into. As they started working with right triangles, like we do in what we call the Pythagorean theorem, they found this number the square root of 2. And as they were working with circles, they started coming across this ratio of the circumference and diameter that we now just call pi. Both of these caused issues because no matter how hard they worked at it, they could not find a ratio of integers that would allow them to completely describe these values. They could not find two integers, a and b, that they could write to meet that definition of rational number. But remember, rational numbers up to this point were the only numbers that they knew. Now they had some numbers that, well, weren't rational. So what do we call those numbers that aren't rational? Irrational. Now notice that for the first time, we're not including the previous layers in this group of numbers. In fact, we're defining irrational numbers as specifically being not rational, not what we've been talking about so far. Even though irrational and rational numbers are two completely separate categories, they arise from the same situations and they're often used right alongside each other. Since they're so often used at the same time, we can just go ahead and put a big circle around both of these groups. When we're talking about numbers that are either rational or irrational, we call all of these together the real numbers. Now, all of that's been pretty simple so far, but that brings us to our last outermost ring of numbers, complex numbers. They are called complex numbers because they have both a real and an imaginary part to them. What makes them imaginary is this I, which is equal to the square root of -1. But honestly, imaginary and complex numbers, situations in which they arise, and how we work with them, all of that is well beyond the scope of this video. So for now, let's just leave it as this last, somewhat mysterious category of numbers. So that's our number system. I hope that this helps you to understand what the different classifications of numbers are and what distinguishes each set from the others. Knowing exactly what a teacher, book, or test means when they use one of these terms will definitely help you understand the finer points of the math that you're doing. If you thought this video was helpful or interesting, hit that subscribe button. Take a few minutes, explore the channel, look at the other videos, and share them with a friend. This has been Montgomery Mathematics, and I'll see you next time.